In a previous video, I asked the question, should you DIY your own mini split? And the responses I received from that video were very intriguing to me, so I wanted to take some time to think about the best way to respond to that. In thinking about the comments, many of you responded with, well, your local contractors just charge too much. I understand that trying to save money is very important. And for others, you felt that installing mini splits really is simple. And to be honest, installing mini splits is not overly difficult. In just a few hours or within the day, you can have your air conditioning system going. However, the number one failure is sizing your units properly. Now, you may say, well, it's not that complicated. The reason why I know you're going to say that is the fact that I was brought up into the trade with a very simple rule of thumb where you calculate the square footage divided by 400 to 600 square feet per ton. And that gives you the size you need, right? Well, is that correct? Well, for many decades, using that rule of thumb method gets you pretty close. Close enough to where with central heating and air conditioning systems, with not so great insulated homes that were leaky, not well insulated, they were built well, but the insulation and air sealing was just not that great. You actually wanted to oversize your unit just a little bit, and that wasn't a problem. But today, homes are getting built more airtight. Insulation is different. We're insulating our homes better with different materials than we did in previous decades. And because of that, it's becoming more and more important to size our air conditioning and heat pump systems correctly. So you might ask, how do I do that? If you are going to DIY your own system, how would I go about making sure I have the right size unit? Well, let's start off with what a professional HVAC company should be doing, and then we'll work out from there. First of all, let me share my screen with you. Typically, we should be using what's called a manual J calculation. It's written by ACCA. It's an organization that gives us a lot of the math and tables we need to design a HVAC system, not only the furnace or air conditioner or heat pump, but also the ventilation systems. That's the part that the HVAC part is hugely overlooked. The proper ventilating is very, very important. But for now, just getting the actual BTU rating to know what size unit you should pick is something that we should discuss. Now, I didn't get it too crazy in this calculation. I started off with a unit that's just simply, I believe I just wrote it 1,500 square feet is all it is. Let me see here. I'm gonna close that up. It shows 50 by 30. It's showing the floor area of 1,500 square feet. So let's just use that for an example. Simple home, simple room. Let's say that there's going to be a kitchen in that room. So we're going to go ahead and turn this into a kitchen. And then we're going to have 8-foot ceilings. You can see that. And then we're going to have 2 occupants with the kitchen. We're not going to get too crazy with this. This is just a simple calculation. And we can see how much already goes into it. Now, with it, we would want to pick, let me start over here. With it, we would want to pick the proper construction methods to be able to make this an accurate installation. So I would go through here and just pick all the things that this house is made from. And I'm just going to leave it a very basic construction. We're going to leave it all. We're going to have an attic ceiling that's insulated. Roof insulations, we're not going to, no roof insulation, but ceiling insulation, we're going to have R30. And the ceiling is going to be gypsum drywall. Let's say we're going to do a crawl space. We're going to do carpet floors. Let's say that we put R19 in the floor, wood frame, 2x12 floors with, yeah, we're going to leave it there. And then we're going to have, I haven't drawn any windows. Let's go ahead and put a door on the east side. Throw a couple windows on the north side, west side, and a couple. Yeah, for timing, we don't want to spend a lot of time. I guess we'll go ahead and add one here. So by adding all the doors, windows, and such, it's very important because the weather and the orientation of the sun, all of these things matter on these calculations. Even just changing the orientation of the home with the north, this being the north side now, that will change the calculation. Now for timing, I could go in and change a lot of the different conditions around this home, but for timing, based on what it's showing here on this calculation, with two people, a kitchen, not a whole lot going on in that house, it's showing that I need 0.8 tons for that room. So is that correct? I mean, if you were to just use the rule of thumb method, you take 1,500 square feet divided by 500 square feet, which is breaking that would be 3 tons for that space, without any consideration to what's going on in that house. That's the old rule of thumb method, 3 tons. But here, with a very simple calculation based on very simple layouts, we're showing that it's just under a ton. So you may not have access to Manual J software like this to go through every little detail to get it just perfect. So how can you do it for free and be a little bit more close than the rule of thumb method? Well, let me show you here. So if you go to ecomfort.com, out of all of the free online software to do Manual J's, this is the one that's the most comprehensive, that has not only room by room details, but it also has a location specific details for sizing equipment. So let's just go over an example. So you log into ecomfort.com, you'll see the opening page here. You scroll down and you'll see this little window, mini split room sizing. Now this is not sponsored by eComfort. I'm just doing this because I shop here with this store, and I use this calculator when I'm trying to figure out something on the fly. The thing I like about it is the fact that you can do a room by room sizing. Now, if you're trying to figure out for your whole house, you really need to take the time to plan out how to zone the house out, what rooms you're needing to treat, and then calculate each one individually and then add everything together. You want to figure it out by zones. Each inside unit would be a zone. Let's say you're treating the kitchen or the bedrooms. You want to treat them differently because you're going to close the doors off, but if you're going to figure out like a one condenser system with multiple heads, I do to be able to figure the outside unit, add everything together to get your BTU rating for your outside unit, and then they'll be pretty close. So in this example, let's go back to the 1,500 square foot basic simple home. For me, I'm just going to put it in my local area, and this is going to be a moist and humid, or moist mixed zoning. I'll show you the zoning map here in a minute. So I'm going to pick the zip code, the age of the home, and let's say we're going to work a kitchen out on this. Then we calculate the load, and here we're seeing that without any other changes, that they're giving us, again, pretty close to 1 ton, just under it. For cooling, and the heating load. But let's go a little further with this. This is, I didn't go very far with the other program. I could have gone through every little detail a lot more. Maybe I could do some videos later doing perfect examples. But here we're going to calculate a desired indoor temperature. And we're just going to leave it at 75 for cooling and then 70 for heating. If you notice here, though, they're giving us the average highs and lows for my area. And now it doesn't work out the what's called sensible and latent loads. That's a whole different discussion too. But it is figuring it out for my local area. Now this is the next step. The next steps to get it a little bit more detailed requires knowing your home, the orientation again, and how many windows and doors you have. But let's just run through this real quick. So in our example, we're just doing it one room where every wall is exposed to the outside. So that's what it's asking here. So our north, east, south, and west walls are all going to be exposed. So let's say yes on all of these. We're not going to worry about the length in each direction. Not in this case. I think what we did do, though, let's just say 30 by 50. And that should get us close to the other example. Let's go to the window details. I think I had one window on the north. I had two on, or one on the, yeah, two, one, two, and then on the south side we did the one door. So it says French doors, but if you see here it says we assume French doors are 3 foot by 7 foot, which is the size of a standard door. Each half of a double door should be counted separately. So to just figure 1 3 foot by 7 door, which is typical for a house, so just count 1. Go to ceiling details. On ceiling details, again, it asks, is it exposed? Well, if it goes to an attic or to a flat roof where it's outside, then we'll say yes. 8 foot ceiling. Floor details, if we do a slab or crawl space, it is exposed again, so we say yes. Now it's asking for our framing, for our wet walls and windows. So we'll pick framing with siding, since that's typical in our area. Now it asks excellent insulation, fair insulation, or no insulation. I tend to go with fair insulation unless it's a really perfectly insulated home. If it's well insulated, built within the last, let's say 15, 20 years, I'd go ahead and use excellent insulation. But if you kind of want to make sure that you're getting a little bit of wiggle room in there, I would pick fair insulation. Now it's asking your window type. Now, if you have a really old home, you probably do have single pane windows. You may have newer windows that are 2-pane or 2-pane with low E. Now, my house has low E, so I'm going to go ahead and pick that. Now, ceiling details, it's asking what kind of ceiling. Does it go to an attic? Or is it sloped with no attic or flat with no attic? So we're going to do ceiling under an attic. Again, with the insulation, I'm just going to pick fair. The floor details, I'm just going to pick floor over basement or crawl space, unfinished. I'm going to pick fair insulation again, submit that. And now it's giving us a little bit bigger unit. So instead of a 3-ton unit, which was by the rule of thumb, or without going through that other more advanced program, which was about 0.8 tons, or this initial, the initial calculation this gave us was just right at a ton. Now it's saying that for our cooling, we need a little over a ton. 12,000 BTUs is 1 ton. So maybe like a 1 ton unit would probably be okay. But in order to get the heating load, we're going to need to have almost 2 tons. So 24,000 BTUs would be 2 tons. You may be able to use an 18,000 or 20,000 BTU unit, but you may want to go ahead with a 24,000 BTU unit just to make sure you get this right. Now, the thing to know about mini splits is that they do not operate at their top rated capacity. And I'll get into it in other videos, but you can actually get the submittal sheets and it'll give you a lot more detailed information for that particular unit. And you may actually get more capacity out of that unit than its basic rating or its nameplate rating. But just for today's discussion, you want to go with a 24,000 BTU 2-ton unit. It's going to work out this load. And that at its top max operation, it's going to provide that 24,000 BTUs. But with mini splits, as you reach the temperature that you have it set for, it's actually going to start ramping down to its bottom capacity. That's what makes these units so efficient, is that they don't operate at 100% all the time. Instead, they modulate down or ramp down. They operate at a very low level, and they only come up and down to maintain the temperature. So that's why humidity is an issue with air conditioning on the air conditioning mode of these units, is because they don't always operate at a level that dehumidifies the room. And again, on a future video, I'll have to talk about. So on a future video, I'll have to talk about sensible and latent heat. There's just a lot to sizing units. There's a lot of information. HVAC technicians go through a lot of training to know how to do this properly. That is, if companies are actually training their technicians. I find in my area that a lot of technicians don't really understand all of these things. And a lot of these guys, they just don't know. They don't know, but they don't know. And that's why I felt compelled to make videos about this. However, I mentioned I was going to bring up one more piece of information. Let me bring up this map here. So the International Code Council, in their International Energy Conservation Code, provided this map in order to help builders, HVAC technicians, and anybody else that needs to know how to design buildings. And this is a very useful map for designing HVAC systems as well. And the fact that knowing where you live and what climate zone you live in will give you kind of an idea of whether you need to deal with hot, humid air, hot, dry air, whether you're dealing with cold air. It's very helpful in understanding how to design for your home and your HVAC systems and other things. So for me, I live in Zone 4 here in Missouri. If you see this little white line here, So if you see this little white line here, anything below that white line is considered extremely hot, warm, and humid. If you live in those areas, it'll be like, yeah, that's true. So if you're down in Florida, the Gulf states, in southern Texas, it is very hot and humid, and even up into the states above it. But see, even as far as Zone 4 here, since I live in this moist area, I still get very hot, humid areas even for us. If you don't size your equipment correctly in our area, you're going to see uncomfortable and moist conditions in your home, which can lead to mold conditions if you're not careful. So if you oversize your air conditioning equipment, even as far as we are up here, you can actually be cold and clammy. And you can have mold growing in your house, even though the air conditioning equipment is keeping it nice and chilly in the house. Humidity levels will be too high. For example, when I first got into doing mini split systems, I put a 9,000 BTU unit, which is the smallest single head unit that I could buy and put in my room. kept the room at 68 degrees. You would think that was comfortable, but when I go in the bedroom and the bed would be wet, and I was like, what's the deal with this? And I got a hygrometer, and it said 68 degrees and 70% relative humidity. And I was like, holy moly. So what was going on there? So that mini split, that ductless heat pump system was keeping the room at the sensible temperature that I had it set for, but the latent heat or the moisture in the room was excessive because that unit would ramp way down, and that inside coil that was supposed to cause condensation just wasn't working. It didn't need to be working because the unit had already brought the temperature down. And so the only way to make that work out was to get a dehumidifier for that room. And so that's how I can control that. But what I'm having to do is redesign my living space in order to make the conditions work for my house so I don't have those high humidity levels. So you're probably like, oh, I don't need all this information. Why are you telling me all this? You're just complicating things. Well, I'm trying to at least make you aware of the things that you can plan for before you just go out and buy a mini split system. Now, they're great. They're making Mr. Cool especially, but other companies are starting to come out with DIY model units that I think are pretty good. You still have to consider the sizing of these units to be correct for the space. A little bit of planning ahead of time will save you a lot of trouble later on. Knowing how to calculate or do a manual J calculation in order to size these pieces of equipment so that you have the end result you want is all I want for you. And so I hope you know that's why I'm sharing this with you. If it's of value to you, I hope that you'll subscribe and join me on later videos. If you think somebody else can benefit from this, please share it with them. And let me know what you think. Is this video good enough? Am I providing you information that helps you out? Let me know with a thumbs up.